Hi friends, welcome back to my YouTube channel. So today I have come up with another previous year question from the UPSC Physics optional, and today's question is from the topic Semiconductor Physics. So the question is, a silicon semiconductor sample at 7 T is equal to 300 Kelvin having cross-sectional area of 0.5 micrometer square has a pentavalent doping profile given by C of x equal to 5 into 10 raised to 6 e raised to minus x by ln centimeter raised to minus 3. Given the mobility of electrons in the sample is 1250 centimeter square V inverse S inverse and the diffusion length of electron LL is equal to 4 micrometer, calculate the diffusion current in the sample at a distance x equal to 2 micrometer. Now this question looks like very tough, but it's not that tough. You need to know the concept of diffusion current in a particular semiconductor. So there is a formula for the diffusion current, and we can first of all write that formula and see whether all the values are given in the question itself or no. So the diffusion current density J D is equal to Q dE dN by dx. Here dE is known as the diffusion constant. So Q is the charge and N is the doping profile. So we have to take derivative of N with respect to x. So instead of N we are given here with C of x. So C of x is equal to 5 into 10 raised to 16 e raised to minus x by ln. Now what we will get if you take dC of x by dx, we will get it as minus 1 by ln 5 into 10 raised to 16 e raised to minus, we have to calculate diffusion current at a distance 2 micrometer. So x become 2 by 2 micrometer by ln is 4 micrometer. 4 micrometer. So these 2 micrometers will get cancelled. It become, in effect, it is become e raised to minus 0.5. Now see this. We are not given with a diffusion constant. So diffusion constant dE is given by Einstein's relation, which is equal to kT by Q mu E, where mu E is the mobility of electrons. So K is the Boltzmann constant, T is temperature, Q is the charge. So when you substitute this in the equation for JD, we get it as Q into kT by Q mu E into dN by dx. So Q's will get cancelled and we will be left with what? K into T into mu E. Instead of dN by dx, we have a value here dCx by dx. So dC of x by dx. Now the question is very simple, isn't it? We just have to substitute the value. Okay, one more thing I just want to say. This is the diffusion current density. So what is the diffusion current? Diffusion current ID will be diffusion current density into area. Area is also given in the question itself. So we can substitute all the values. So ID is equal to 1.38 into 10 raised to minus 23 into T is 300 into mobility is 1250. So that is given in centimeter square. So we can write it out as 10 raised to minus 4. Therefore this becoming meter square. Then dCs by dx. The value is minus 1 by L is, what is the value of L? L is 4 micrometer. So we substitute as 1 by 4 into 10 raised to minus 6 into 5 into 10 raised to 16 into e raised to minus 0.5. So I think this up to this everything is clear to everyone, e raised to minus 0.5. Now we just have to do the calculation. So when you do this in the calculator, you are left with the value 1.96. Okay, multiply this with area. Value of area is again given in the question, it's 0.5 micrometer square. So converting it into meter square, they will be minus 12. So we will get the value as 1.96 into 10 raised to minus 6 ampere. Now you can just do the calculation by taking the units it's only, and you can verify the result that you will get this value in amperes, because all the units are given in the question. So we can substitute those unit and we will find that this value is correspond to the ampere. Okay, so this is how we can do. So there is nothing you need to worry about. Only thing you need to know what is the current density, and once you know the current density and the profile, you have to take dn by dx and then substitute for diffusion constant from Einstein's equation, and when you substitute, the values for q will get cancelled and we will left with a very simple equation, and into that equation you have to substitute all the values and you will arrive at this. So I did the calculation in hurry, so you can again recheck whether you are getting 1.96 to the raised to minus 6 ampere. So this is like, okay, the current is microamperes, which is obvious. This diffusion current in a semiconductor will be very less. Oh, this is in micrometer unit. Okay. Okay, so we will, I think everyone understood this question. So we will come up with another question in the next class, in the next video. So till then, goodbye.